Hi, today we're doing another video, and we are doing another math blooper, which is something that I started a few days ago, and I just wanted to do another one because it was cool. Well, because it gives you a little bit of tricks that you could do to kind of skip your way out of doing a bit of math. And today we're actually doing more than just tips. We're actually doing tricks that you can do to amaze your friends and make sure that you kind of like think that you're a wizard or something like that. So it goes like this. Whenever you try to multiply by 9 or when you try to multiply by 5. Today we're doing something that tries to multiply by 6. So whenever you multiply 6 by so we're going to try and multiply it by 8. So whenever you do any even number, you can just see what happens. So multiply 6 by your number. Well, mine is 8. So, and I already know this. It's 48. Now multiply 6 by another number. I'll pick 6 by itself. Then you get 36. Whoops. I have a habit of doing that when I accidentally press shift while pressing numbers, so. And I'll do it by another number. And then multiply that again. And then do another number. Are you seeing a pattern here? So basically, whenever you do a number, the last digit is the number that you multiply by. In the first digit or the tens digit or whatever digit you have is half of that number. Let's try it with 12 though. Stupid habit. So we know 12 times 3. Well, we know 12 times 6, which is 72. So, how would this work? So basically, half of 12 is 2. Half of 12 is 6. So, so this is going to be similar to one of our other tips, but instead of doing 612, which is irrational for 12, you add it to the second digit, because it's supposed to go to the second and third digits, and it's supposed to start with the second digit whenever you multiply it by 6. So if it goes past the second digit, you just add the second digit of the first of the number that you multiply 6 by, and then add it with the number divided by the number that I already said. So like 12 half of 6. 6 plus 1 is 7. And 7, 2. 1, 2. 60 plus 12. It'll even work with larger numbers, such as 57, which will be well past 100. And it's just a really cool tip that you can do to get out of it, but just know that it only works with even numbers. So imagine trying to do it by 3. 6 times 3 equals 16. Well, 18, which is not 3, as you should know. So it only works with even numbers, which is kind of a bummer, but it's still something to think about, and it's still something cool that you can do to get it out of doing a bit of math. And I'll come to you now with another blooper. Okay, so we're back, and now we're doing something that you can easily figure out how to multiply quick numbers. So we're going to do from 1 to 10. There are a few others that you can actually do 12, up to 12. But I'm not going to do those because it's going to take a little bit. So it actually will not work for 7, which is kind of disappointing, but it's still pretty cool because 7 it gets kind of complicated, and all you see is just gibberish, and no one wants to think about that gibberish. So just multiply it the regular way. It's kind of boring to know that you can't figure out if it's divisible by 7 or not easily. But let's just get on to it. So 1 you can do with any number, so we already checked that off. But 2, so you can just have a bunch of random numbers at the beginning. So long that you can't even see the end. But as long as the last number of the digits are available to be a number that's divisible by 2, then all of this will be divisible by 2. Because like 50, the second digit, so this digit is not divisible by 3, and nor is 50, the second digit of 50 is not divisible by 3. But it still is not divisible by 3. But the whole number is still divisible by 3, so it doesn't really matter. So it doesn't really matter whether any other numbers or any other digits actually aren't divisible by 6. It doesn't matter of all these numbers. It just matters whether this is 4, or this is 6, or this is 8, or this is 10. Well, it can only go to 2, 6, 4, or 8. But there is an exception, which is 0, because it's basically going to be the same thing as 10, but in a less form. So it's basically just 10, but it's just not. It's just 10, but not. So we have that done, and then let's go on to 3. So all the numbers. So for 3, the way you know that it's divisible by 3 is if all the numbers are divisible by 3. So we have this. So 2, 6, and 8. So 2 plus 6 equals 8. 8 plus 8 equals 16. But 16 is not a multiple of 3, so it would not be able. So you would not be able to multiply it by 3. But if we add an extra, let's say 2, 6 plus 6, 2 plus 2 equals 4. 4 plus 6 equals 10. 10 plus 8 equals 18. And 18 is divisible by 3. Oops. 18 is divisible by 3. So it won't. Just so you know, these tricks won't tell you exactly how much they're divisible by. They'll just tell you a quick way of knowing that they're divisible or not. So you don't have to waste your time in trying to. And you can check if they are. It's a quick way to get a viability. Validate that your answer. It's a quick way to check if your answer is valid. So for the last 2 digits need to be divisible by 4. So again, it doesn't matter if any of this is just gibberish. It just needs to make sure that the 2 last digits are divisible by 4. So 32 would work. 54 would not, because it's not divisible. But it can't be like this and leave this out, because again, this is not divisible by 4. So no matter, and it wouldn't matter because 100 is divisible by 4. So it wouldn't really matter for the rest. So if 100 is divisible by 4, or, whoops, 1,000 is divisible by 4, and 10,000, and 100,000, 1,000,000, and so on and so on. So that's a quick way for 4. And 5, well, this should be easy. It's only divisible by 5 when the last number, it doesn't matter if it's Ghibli-dish. The last number just needs to be a 5 or a 0. So if it was a 5 or a 0, it worked because 10 is divisible by 5, and 10 is just another is a greater form of 0. So this would work in any of these situations. 6, it needs to follow the rules of the number 2 and the number 3. So it needs to have the last number needs to be divisible by 2, but all the other numbers needs to be numbers. So you can't just put gibberish in the front, because if this were to be just a number that wasn't divisible by 3, it would be useless, because it's both divisible by 2 and 3. As for 7, it's just gonna look like a bunch of gibberish, just like all over the place. So we're just gonna skip it. 8, however, it needs to follow the rules of 4 and 2. Well, not the numbers of 4 and 2. Instead, it needs to be a multiple. The first 3 digits needs to be a multiple of 8. So, like, 100 is not a multiple of 8, so if it's just gibberish in the front, any numbers in the front, it wouldn't really matter, because this 100 not divisible. But if it was 100 and, let's say, 104, that would be okay. For 9, the entire number needs to be divisible by 9. So 1, 2, 3, that would not work, because it's not a divisible of 9. It may be divisible by 3, which means 3 is okay, but 9 is not. So instead, you would want something such as 135, which is a divisible, which is exactly 9, so that would be divisible. So I've kind of been rambling, so let's quickly get to 10. So 10, it should be fairly straightforward. It can only end with a 0. It doesn't matter what's in front of it, like this. It doesn't matter, it just needs to be divisible by 10. Well, it does need to have a 0 at the end, because, well, this would be divisible by 10, this would be divisible by 10, even if there was just a 1. Or a 0 and 1. A 0 and 1 billion. Whatever this number is. Even if it was that number, all this would be gone. So it needs to only end with 0. So that's it for today's video. Hit subscribe, hit the bell, smash that like button, and make sure that you leave a comment, and I will try to make the video better by your comments. Bye.